Hi, myself is Nitin, and today we are going to discuss the Programmable Logical Controller, which is also called as the PLC. The PLC it is an industrial computer widely used for industrial automation for controlling, monitoring, and diagnostic of any process parameter in any kind of industry. Before PLC, relay logic were widely used for industrial application, but there were some limitations for this relay logic. Now, in order to understand those limitations, we'll consider an application where we want to control the level of the tank. Consider one tank which is having input sensor, one at low level sensor and another at high level. So we're having two input sensor, low level sensor and high level sensor. Now consider one input line which is feeding the liquid to the tank and which has on off wall. Once the wall is on, the liquid can come to the tank. And when the wall is off, liquid will stop coming to the tank. Now consider at the bottom of the tank or outlet of this tank, there is a pump which can feed the liquid to another equipment. Okay, so application is such that once the liquid falls below the low level, the pump should stop and the wall which is at inlet of this tank should open so that liquid can come to the tank and tank will start filling. Once the tank level reach to high level, the input wall which is feeding the liquid to the tank should stop and pump which is at the bottom or at the outlet of the tank should run so that it can feed the liquid to the another application. Okay, and once the liquid falls below to the low level, pump should stop and again the wall should start to feed the liquid into the tank. Now we'll see how the relay logic were developed for this application. Now we're having two sensor to sense the liquid level, low level sensor and the high level sensor. Once the liquid falls below the low level, the value of this low level sensor will be fed to the relay. So relay will store the status of this low level sensor. Once liquid reach to the high level, the sensor will sense this level and it will trigger the another relay. So the value of this high level will be stored in another relay. So for the input, we are having two relays. Now we'll consider on output side. On output side, we are having on off wall, so we require one relay for the on off wall, and at the downstream or at the bottom of the tank we're having the pump. So consider we are requiring one pump, one relay to start or stop the pump. Okay, now based on application, the wiring of this relay will be done in such a that once the liquid falls below the low level, pump should stop and the on off wall should open so that liquid can fill into the tank. And once this liquid start rising to the high level, the pump should stop and on off valve should uh, on off valve should stop and pump should start. Okay, now but there were some problem, like if operator want to change the logic, like operator want to introduce timer or counter in this logic, then he has to add one hardware and he has to change the wiring. So that were the first limitation. So changing the hardware or changing the wiring, it's very difficult when the plant is running. That is one thing. Second thing is that operator will not get any kind of the diagnostic information. Like operator wants to see what is whether liquid is at the low level, high level, or where exactly. So he will not able to see those diagnostic information. So considering this limitation, new electronic device which can be programmable as per the operator's requirement and operator can change the program any number of time were introduced in market called as programmable logical controller. This is electronic device and can be programmable in different ways and many times. So that's why it is called as a programmable logical controller. And it has the Advantage that any process parameter which can be controlled, monitor, and diagnostic. Also, you can do the program as per the requirement. You can do the program many times. You can change the program. Another features like advanced mathematical calculation, complex mathematical calculations, timer, counter. So these kinds of the instructions or this kind of the functions were available in the PLC. Another thing is that the PLC can communicate to the HMI. PLC can communicate to computer. PLC can communicate to the other devices, and which can also support the different kinds of communication protocol. When the PLC were earlier introduced in the market, it were used only for digital input and digital output. But nowadays it is very widely used for the analog input and the analog output. Nowadays there are different manufacturers like Allen Bradley, Siemens, Mitsubishi, Schneider. Those are manufacturing the PLCs, and there are different very wide variety of the PLCs is available in the market. Now we'll see the basic components of the PLC. First component is input module, which is which sends the all the inputs and stores this value in input register. Another next module is output module, which gives the uh, out which triggers the output devices like pump, motor, valves. Third component is CPU, where all arithmetical, logical operations executed, where the all this executable program will be stored inside the CPU. Next component is power supply module, which feeds the power to the PLC. Now we will see how PLC works. PLC works in 4 steps. Step number 1. In step number 1, PLC sends the all inputs and stores the value of this input into input registry memory. In next step, the PLC execute the program which stored in CPU, and depending upon this program and the status of the input, it generates the output and store in output register memory. In third stage or third step, PLC will use the whatever value stored in output registry output register memory. It gives the values to the output module, so that output module can trigger or activate the output devices like motor, pump, valves. And in fourth step, PLC do some internal calculations like updating the timer, counter, communicating with the HMI, communicating with the other devices, communicating with the computer. So, and these 4 steps keeps on repeating again and again, but very fast. So these 4 steps combined called as the scan time of the PLC, and it is in millisecond. There were some PLC which requires to operate at a very high speed, and which is very widely used in emergency shutdown system, fire and gas system. So depending upon the requirement, the scan time of the PLCs varies. So in today's topic, we see what is the PLC, why were it introduced in the market, what are the basic components of the PLC, and how PLC works. So that is for today's topic. Thank you.